You know, in hospitals, labs, and even some places you might not expect, there's this unsung hero working behind the scenes, making our world a whole lot safer. It's a machine called the autoclave. And in this explainer, we're going to pull back the curtain and show you exactly how it works.
Okay, think about this for a second. You've got a busy operating room, a super modern tattoo parlor, and a cutting-edge microbiology lab. I mean, what on earth could possibly link these three places? They feel like they're from completely different universes, but they are all built on one single fundamental rule. And that rule? The need for absolute sterility. And I'm not just talking about being clean here. I mean the complete and utter destruction of all microbial life. The machine that makes this possible, well, that's the hero of our story, the autoclave.
All right, so here's what we've got on tap. First, we'll talk about what this unsung hero actually is. Then, we'll get into the science of why it's not just about heat. After that, we'll tackle the challenge of getting the air out, figure out how we prove the invisible was actually accomplished, and finally, cover the crucial topic of handling these things with care.
So, what is this thing really? Well, at its core, an autoclave is a machine that uses the simple but powerful force of pressurized steam to sterilize equipment. And when it comes to decontamination, it is, hands down, the most dependable system we have. Period.
And we have to be super clear about what sterilization means. This isn't just wiping something down with a cloth. We're talking about the total annihilation of every single microorganism. Bacteria, viruses, fungi, even the toughest bacterial spores. For surgical tools or delicate lab cultures, anything less than perfect is a total failure. There's just no middle ground here. An item is either sterile or it isn't.
So how does it pull this off? It's really easy to think of an autoclave as just a very, very hot oven, but that's not quite right. The real magic isn't just the heat, it's the steam.
Think of it like a recipe with 4 crucial ingredients that have to work together perfectly. First, you need that intense temperature. We're talking at least 121 degrees Celsius or 250 Fahrenheit. Second, you need saturated steam, which is the secret agent that actually delivers all that heat. Third, to get the steam that hot, you need pressure. And finally, you need time. You have to hold it at those conditions long enough to guarantee everything is gone.
Honestly, the simplest way to picture it is as a huge, superpowered pressure cooker. You know, a pressure cooker at home. Uses steam to cook your food way faster. And autoclave just takes that same principle and cranks it up to achieve complete sterility. It's that immense pressure that's the key. It lets water vapor get way, way hotter than its normal boiling point.
This view really shows you the elegant physics going on inside. First, steam flows into the outer jacket, which preheats the main chamber. Then the real show begins, as steam floods the chamber itself. And because steam is lighter than air, it fills up from the top, naturally pushing all that colder, heavier air down and out through a drain at the bottom. Pretty clever, right?
Now, that little detail, pushing the air out, is actually one of the biggest challenges in this whole process. Why? Because air is the absolute enemy of heat transfer. If you get even a tiny pocket of air trapped inside, say, a wrapped surgical pack, the steam just can't get to it. That one spot won't get sterile, and that's a massive point of failure.
So, how do you get rid of those sneaky hidden air pockets? Well, autoclaves basically have 2 main strategies to solve this problem. A passive one, called gravity displacement, and a much more active one, known as pre-vacuum.
And you can really see the trade-offs here. That gravity method we just saw is simple, it's reliable, and it's great for solid things like glassware or liquids. But the pre-vacuum method, that's a whole different beast. It uses a powerful pump to literally suck all the air out before any steam even gets in there. This is way more effective for tricky, porous items like fabric packs or complex instruments. But, as you can probably guess, all that performance comes with a higher price tag and more complex maintenance.
Okay, so this brings us to a really important question. Sterilization is an invisible process that kills invisible things. So after a cycle is finished, how in the world do you prove that it actually worked? It's not like you can just look at a scalpel and see that it's sterile.
So, your first line of defense is what's called a chemical indicator. You've probably seen these. It's that special tape or a paper strip with ink that changes color when it gets hot enough. It's a fantastic quick check. But
Here's the catch. All it really proves is that the outside of the pack reached the right temperature. It doesn't tell you a thing about what happened deep inside. For the absolute, undeniable proof, you have to go biological. This right here is the gold standard. It's a small vial filled with some of the toughest, most heat-resistant bacterial spores known to science. The logic behind it is just beautifully simple. If your autoclave is powerful enough to kill these guys, it can kill absolutely anything else.
And here's what they look like. After a cycle, you take the vial and you incubate it. If the spores somehow survived, they'll grow and turn the liquid inside yellow. That's a fail. But if the spores were destroyed, the liquid stays its original purple color. So here's the key takeaway. When you're dealing with biological indicators, no change is very, very good news. Now, it goes without saying, any machine that uses extreme heat and intense pressure is, by its very nature, dangerous. So the final and maybe the most important piece of this whole puzzle is the human element, operating the autoclave safely. And this part is completely non-negotiable. You have to have the right personal protective equipment. That means a lab coat, safety glasses or a face shield, and most importantly, thick, heat-resistant gloves. You cannot underestimate the danger here. The items inside and the steam itself can cause horrific burns in the blink of an eye.
And listen, the danger is not over just because the cycle has finished. Unloading has to be done by the book every single time. Step 1, make sure that pressure gauge reads 0, no exceptions. Step 2, stand back and crack the door open, just an inch or so, to let that superheated steam start to vent. Step 3, now you wait. A full 10 minutes. Rushing this step is a huge mistake, and only then, with all your PPE back on, can you safely start to remove the items.
So, as you can see, the autoclave is so much more than just a machine. It's the silent guardian of a really fundamental promise. The promise that a surgical instrument is safe, that a scientific experiment is pure, and that a patient is protected from harm.
It's really just a remarkable piece of engineering, quietly working behind the scenes. Which kind of makes you wonder, doesn't it? What other invisible processes like this are out there, protecting us?